Hello. So we're finally now getting ready to do the Pythagoras activity we've been preparing for 2 days, and I finally got everything, all my ducks in a row, all my bits of printing done, cutting out done. We're not doing all the activities. We'll leave especially the ones for the older ages for you to do. I'm going to do a little demonstration. If you can watch last night's one, it was a preparation one. It's at 8 p.m. Basically, it's the one before this. My 5-year-old grandson came on, and he's the expert 5-year-old in this group, and he did the activity his way, so that can give you some guidelines. And also, if you're either one who doesn't know what to say at all, there's questions in this activity, and if you're an older sibling, to work with your younger sibling, watch that and see and read the activity to see what questions to ask to help your younger sibling learn. And basically the idea is they learn for themselves. They learn by experimentation. If you watch that, you'll see he doesn't even know why he did what he did. He put them in order, and he doesn't know why he did it. When I said, "Why did you do that?" He said, "Because yes." It was just obvious to him. It was logical, and it was just there it was. So we're going to go back and do that one. We're going to go and do them all. I am going to alternate, going to make me a bit dizzy, between the activity, which I believe is here. Let me make sure it's all lined up. Yes, it is. And so we're going to do the early years activity at 10 in a few minutes. So I'll leave that till then. But in the meantime, I'm going to share this screen and then alternate between that screen. So we're going to be popping in and out. Let's see. I'm going to get so good at doing this by sheer practice. Got everything lined up, I believe. So the first thing we're going to do is look at this. Share. So this is the activity. That's the early years. We're going to come back to that later. And oh my goodness, with all my cutting up and getting my printing out done, I still haven't done the history. So you know what? That means it's for you to look. We'll have a look at the activity, and it's for you to investigate all the different activities here. So we're going to start off with, there are lots and lots of different ways. It's called the proofs of the Pythagoras theorem. What we're doing here is basically demonstrating, and it can be done geometrically, which means that you see this one here. So this is going to enable us to see that, for those of you that know a squared plus b squared equals c squared, it basically means there's a square. If you take a square, we'll see that in a minute, but all these different ways of doing it are ways of proving Pythagoras' theory. Now, what we're doing here is getting a feel for it, because we're doing physical activities and matching and mixing, and not matching and matching, cutting and mixing. It's all jigsaw puzzles. So we're going to play with jigsaw puzzles, which is going to give us a really good, strong feel for this Pythagoras theorem thing. So if you're 7 or 8, you might not have ever heard of Pythagoras, although you might have heard people mention Pythagoras. It's not about Pythagoras. It's about squares and it's the story of a right angled triangle. It's what it's all about. It's all about, and I'm going to change, no, I'm not. I'm going to show you here. It's all about a right angled triangle. That's what it's all about. And the relationship between this edge, and this edge. That's what it's all about. And we're going to see it in lots of different ways, and how these edges, if we make them into squares, boom, 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 a square on every edge, how they fit together. And so that we're going to stick with that. And so we're going to go to the first activity. So here's the first activity. So we had to make, I'm going to change, so make 2 copies of this. So this is super important for you to print it out, find a way of printing it out. This is really hard to do, because I had attempted it, because I don't have a printer where I am at the moment. It's really hard to do by drawing it. I've drawn one of the things for the early years. But everything else, I did find someone to print it out, and the printer hasn't printed out the full colors. It didn't have the full colors. So I've got an extra challenge on my hand. But there's 2 of these, so you want to print them out and cut them out. And then the activity is cut each copy into 6 pieces. So now I'm going to change the screen. I actually have to stop the share and start again. Hello. And share the screen with the visualizer. Here's the visualizer. Ooh, focus. Thank you very much. Focused. And now I've got one of them cut out. Let's see what we've got. Cut into 6 pieces. First thing, we've got it cut into 6 pieces. I've got white. We've got how many triangles? We've got 1. Compare the triangles. We've got 1, 2, 3. I'm missing 1. Got itty bitty little one here. And there's 1 missing. Is it in my book still? Let's see if it's in my book. Da-da, da-dee, da-da. Yo. Okay, we're missing a triangle. A triangle has escaped. We have an escapee triangle. So the one that we're missing is one of these, which has come out green. Yes. So which one is it? Is it that one? Is there a difference between those 2? I don't know. Let's cut one of these out. They look as though they are congruent triangles to me. Let's see if they are identical. If they are simply a rotation and transposed, it's rotated and transposed. So there you go. I've kind of given you, and it is that one because this one has the blue line. Right, now, so we're comparing the triangles. What are the similarities? What are the differences? These are supposed to be pink, by the way. And then we've got this little one here. What do you say? What can you say about all these triangles? So it's up to you. You can look at, do different things with them. I'm not going to do too much with them. And then we've got this shape. What are we going to do with that shape? Right, let's have a look. So compare the triangles. What do you notice? Now we've got to put the pink triangles and the white pieces. So we'll take away the green. We want to use the pink triangles and the white pieces, that's 2 white pieces, to make a square. Well, I'm not going to do it for you. So that's the jigsaw puzzle. Move those around, manipulate the pieces, move them around and see what you can do. Now, I'm not certain, in fact, I am certain that whilst they're the same, you might have to use the mirror image. You might have to turn them over. Just bear that in mind. Think 3D. You might have to turn them over and use them that way. Okay, they're still a triangle. The dimensions are still the same. They still have a right angle. And then this, again, you might have to, I don't know. I haven't done it yet. So that's the first activity. Now this activity, let's see what else. Once you've made the square, make a notice what you notice about it. And then the other thing with that is do print this out. Use the activity. There are questions throughout. What do you notice? What do you notice about the triangles? What do you notice about the square? Now, the next thing we'd do is take the green triangles, put the green triangles and the white pieces together. So the green triangles and the white pieces together to make 2 squares. So all the green triangles and all the white pieces together to make 2 squares. And what do we notice about that square? To make 2 squares, what do we notice about that square? And then you'll have realizations about the activity. Okay, so that's a challenge for you. Now we've got, I'm going to stop that screen and put this one on now. Put this one on for you to see. We've now got 2 right-angled triangles. So I'm going to get rid of these triangles and find my bits where I cut those out. So we're going to cut out the 2 copies. This is easy. This was only a few cuts. This didn't take me very long at all. And cut 1 to make 2 triangles. Well, oops, I cut them both to make 2 triangles. Place the 3 triangles, so we have to pretend one's 1. I've got some sticky tape, I've got it here with me. So we have to put 1 back together. Is that it? No, is that it? Oh, that's not helpful. Go away. Do you get Adobe Flash Player coming and annoying you? There we go. I've put that one back together, so we'll leave that one still. Okay, now I didn't follow the instructions, right? It was just cut 1. So only cut 1 of those 2 and place the 3 triangles to show how the angles correspond to the angles in triangle ABC. So this is obviously for older learners. And just follow the instructions. What are the scale factors of making an enlargement? And what can you deduce about the lengths of D and E? So we've got D there and E there. And what if you add D and E? So this is obviously for much older learners. This is for 14 to 18-year-olds. And that's the activity there. Let me change the screen and show you what I've got. Stop share, share screen with my visualizer. So there we've got, whoops, actually sharing it would be helpful. There we go. And so I've got that one which I've fixed. So don't you cut the whole thing out. That's not what you want to do. You want one that stays the same. You've got 2 more. And you're basically looking at making an enlargement of that shape using these other 2. And I'll let you do that. Right. I'm not going to take away your fun. So the next thing is stop that share and go back to this share. Boing, boing. Now, I had lots of fun cutting all this lot out. Now, what have I done with it? Where have I put it? Oh, dear, 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 dear. Oh, my goodness. What was I thinking? I've put them all on the table here. And it's actually not so easy to collect them. They're a bit mad because they're quite small. So you might want to enlarge that, not just print it out, but actually make a larger copy of it because these are quite fiddly. Now this activity is aimed at primary, so age 8 to 11. Now you can do this with early years and literally just let them play. But what you want to do here is recreate that tree. And the way you recreate it is you're going to use the triangles that you've got. And I don't even know if I've got to get ones. It's a bit like, so I'm just going to, I don't even know if I've got this right. They've got to be right angled triangles. I'm not sure if I've got that right. I think that one wants to go there. So it's, and you're looking at the picture and then seeing if you can create it. Now, is that the correct triangle or should it be the square or should it be that one? Are they the same size? Which one should you be putting where? So this is perfectly, now you might want to print out multiple copies of this. You don't have to print out the whole resource, just maybe multiple copies of some of the pages. This one will definitely be worth enlarging if you can manage it. And see if you can work out where all the squares and the triangles go. And it tells you, so where it says the number 2, 1, and 4 there, that is, I think, so 4 of these, 1, 2. That's 2 squared to make 4. So what's 2? Not quite sure what the 2 is. There's a 2 here somewhere. There, that one. Does it actually? I can see clearly that 4 is 4 of these little squares, I'd say. That one might just be the area of 2 of these little squares. We don't have, yes, it's twice. So if you were going to cover a cake, that was at the top of a cake, and that was the top of a different cake, you'd need twice the amount of icing sugar, twice the surface area for that one as with that one. So the edge length, it's not twice the edge length, it's twice the area. So it's twice the amount of icing sugar that you'd need to cover a cake. Okay, I'm pretty sure that's what it is. Okay, oh yeah, so okay, work out the areas. So this is for upper primary, so this is definitely 8, probably 9 to 11-year-olds, and absolutely valid activity all the way through secondary. This is again a fun activity, and it gives you such a strong sense of, this is that right there is, oh, what are you looking at now? Hold on, double check what you're looking at. Hold on 1 second. What am I sharing? I don't know what I'm sharing, so I'll just make sure I'm sharing the right thing. So you were looking, I think you were looking at the other activity. So now I have managed to, I think might be the first one. You've got to get all those squares in the right order. It gives you a super strong sense. You're going to do it again and again and again and again and again for all different sizes. And that's make, inside there, you have a right angle triangle. I'll just put a dot, which is the right angle. Oh, nice contrasty color. And we've got, well, it's not a dot, a square. Doop, 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 doop. Whoopsie. Little square there. That's the right angle triangle there. And you're going to make lots and lots and lots of those in the process of making the tree. And for those of you that are ready to do areas, then, so if you haven't done areas yet and it's too soon for areas, don't have to do areas. You'll do those next year or the year after or the year after that. For those of you that are doing areas, then look at it and see, work out. Now remember, that is your unit edge length. That's edge length 1. So you can work out, and you've got numbers on the image in the activity to help you see if you can work out what the areas are. You can work out the areas of the squares as well as the areas of the triangles. Now, the next thing, this is not about working everything out. This is about discovery. This is about exploration. This is about getting a feel for, in this case in particular, right-angled triangles. Right, and then once you've done this one, create your own Pythagorean tree, which is what we're calling this. It's a tree made out of Pythagorean triangles, right-angled triangles, and the squares that go with it, and just have at it. Go crazy, create a massive, great big poster of Pythagorean trees, of Pythagorean forest. If you're on holiday at the moment, what a great way of spending. Do a bit of precision. You've got to make sure the edge lengths are precise, and you've got to make sure that those right angles, so that bit there is a right angle, and so you can draw right angle triangles, draw the squares nice and precisely that match them, and then another right angle triangle, and I'm sure you can come up with other ideas. It doesn't have to be a tree. I wonder what else you could make. So that's the next activity. Then we have, here comes the history. So I do want you to Google this, and there's a website in a moment, but we've got Babylonian 3,000-year-old stone tablet right here, where you've got the proof about the area of this looks like the area of a square. There are right angled triangles within that. So this is mathematicians looking at squares and triangles, right angled triangles, 3,000 years ago. 3,000. Now wait a minute. 2,000 years. We're in year 2020. So it's, when was that? This is like what we call, well, we started in the year zero. It's the Christian calendar. Some of you don't even work with the Christian calendar. It's still 3,000 years ago. So imagine what the world was like. Now, I don't know about for you, but in England, in the UK, the British Isles, let's say, where I come from, 3,000 years ago, don't think there was any maths happening at all. 3,000 years ago, do you know what? I need to find out what was happening 3,000 years ago. There were people living in villages, and they were making tools using, I think, metal 3,000 years ago. They have different ages, and in different places they have different, but I don't think anybody in the UK had, in the British Isles, had any concept of math. They were possibly using their fingers to work out, I don't even know what. I'm really glad you asked me that question, because now I need to find out, and that's exciting me. I'm thinking, ooh, what were people doing in, well, the country of my ancestors, that's Scotland, what's now Scotland, England, and then Northern Europe as well, as my ancestry. And also I had some Spanish ancestry. So in the Mediterranean, what was happening 3,000 years ago? I know what was happening here in Babylonia. Look, they were doing mathematical analyses of triangles and squares. Good grief. Interesting. Now, oh, what? Oh, okay. 1,500. This is even before that. The next one, cuneiform numbers in base 60. Woo! Again, they're talking about right angled triangles, because they're talking about the root 2. They worked out root 2. For any of you know what root 2 is, a square root of 2. So if you do 2 squared is 4. 2 times 2 is 4. So the square root of 4 is 2, because it's 2, whatever number times itself makes a number, the square root of it is the number that you times by itself. And they were working that out, which is a complicated thing. And that root 2 shows they were thinking about right angled triangles, basically. And that was 3,500 years ago. And then we got our friend Pythagoras. He was 2,500 years ago. He was the one that was working on all of this. And now, certainly 2,000 years ago, the Romans invaded the British Isles. So they brought a lot of culture with them and a lot of education with them. So whilst they were invading the country of some of my ancestors, they were also edifying the country. So yes, there were negative things about it, but there were also positive things about it. So that was 2,500 years ago. Go and look on a calendar, work out what was happening in your country. And not just your country, but you might have been like me, you might have many countries of your ancestry, where your ancestry goes. So think about what your ancestors were doing 2,500 years ago. And then what have we got here? Again, 500 to 200. So around the same time as Pythagoras, we have in China, they were looking at the China theorem, known as I hope I pronounce this even vaguely right, the Golgool Theorem. Again, people thinking about right angled triangles. And look at that one, that's interesting. We've got 1, 2, 3, 4 right angled triangles, and in the middle you have a little square, which is a smaller version of the square on the of that outside, and then you've got another 4 triangles all the way on the outside. This is really cool. And then if you click on that link or just copy paste the link, check out a lot of the history of this. So that's so cool. And look at that, for this activity, the younger learners just enjoy doing the jigsaws, and whatever age you're at, you can get involved in looking at areas and looking at the comparisons between the triangles and the squares. So this is the activity for early years, which we'll be doing in half an hour. And then, right, here we go. Here's the next one. So what we're going to be doing there is cut out 2 of the copies. I'm not actually going to exactly do it, but I'm going to get away. There's my little friends here. I should have put them straight into a baggie, because I should be doing those with my niece and my grandson over the weekend. Where are my sheets? What has happened to my sheets? Here we go. Now, what are you looking at right now? You're looking at this one. So you've got the green and the yellow and the orange, and look what happened to my printout. Here we go. Look what happened to my printout. Copy this. Stop share, that's it. And now, hello. Share screen. Look here, look, we had orange and yellow and green, and look what happened to mine. Poor me. Here we go. So as I say, I don't have my printer with me, and the person who's very kindly printed this out for me didn't have a full set of colors, but you know what, still got it to print out. So what we're doing with this one, again, cutting 2 copies. I'm going to look at the instructions. Okay, that's fine. Cutting out both of these and then mixing up all the pieces. And this says, this little yellow square shows that there's a right angle there in that triangle. So this is for, this activity is just a jigsaw for lower primary, that's 5 to 7-year-olds. And so cut them out, use 7 pieces to make exactly that. So once you cut it up and mix them all up, make this again. And what you can do is you can use tracing paper. I'm going to use this just for now, just to demonstrate. That's not going to be a very good demonstration. This is quite thin paper. Use tracing paper to draw the outline. So there we go. So use a ruler as well, not just the tracing paper, but use a ruler to make straight lines. So you're just going to, if you've got wax paper in the kitchen, I'm going to go more past it because this is not very transparent, as you can see, but you can use wax paper. If you've got tracing paper, grand. And so just draw the outline. That's all you need to draw is the outline. I've got a bit of carbon paper. You could also use carbon paper to draw it onto something else as well. So put it underneath. If you've never used carbon paper, I haven't used any for years, but I managed to find some in Spain. So in Spain, they still have carbon paper. When I first used carbon paper, I was 11 years, I probably used it before that. Yes, I used it before that in school to trace things, because we didn't have copiers or anything. You had to trace things out. So you can still do that now. And I'm just drawing the outline. That's the important thing of what I'm doing. And I started typing for my dad, who lived in Spain, and he, in those days, you had to do import and export documents, which he imported and exported clocks. And you had to type them in triplicate. So it's three copies, probably 4 copies. The one on top, I don't know if it was 2 or 3 more, but I think it was triplicate. I'm not 100% certain. So you had to line up all the bits of paper, put carbon paper in between, and then type really, really heavily. And if you made one mistake, you had to start all over again. You couldn't rub it out or anything like that. It had to be 100% right. And that's how I learned how to type at the age of 11. So here we go. Now, what am I showing? Oh my goodness, I'm doing it again. You're not looking at the right screen. Oh, blah, blah, blah. Share screen with the other one. Visualizer. Love my visualizer. Okay, so I've actually gone through the whole process of doing this without you even watching what I'm doing. So I'm using this. I can barely see it through here. if you've got tracing paper, grand. If you have this paper, you can more or less see through it. It doesn't have to be super accurate because it's just giving a guideline. I'll show you what I'm doing in a sec. Now, wax paper, the kind of paper that isn't too waxy, just the light wax for the kitchen, it's great for this. It's really great. Get loads of that. You can do activities like this and use it for lots of things. So I've now got an outline. So cut all those up, mix them up, and then have your young learners, oh, you can do it too, put it back together again without looking at that. They've got the outline. That's all they need is mix them all together and make it again. So this is again age 5 to 7, 8-year-olds. I think it's a great activity for any age. Really get your head around it. The more you visualize these things, the more you solve these problems based around right angled triangles and the squares that work with them, the more familiar you'll be, the better understanding you'll have of them. So use 7 of the pieces to hold on. From the pieces that are left, use the 4 orange rectangles, which are actually these are supposed to be orange, these rectangles here. So the rectangles are the quadrilaterals that are not squares, the ones where you have one edge that's longer than the other edge. And use those 4 and the purple square, which I'm guessing, see, my printout is a bit messed up. You can look at purple square, you can call it the pink square. So use those and that to fit exactly into the green square. So 1, 2, 3, 4 plus that to fit exactly, move them around till they fit exactly into the green square. And then what does that tell you? Once you've fitted those 1, 2, 3, 4, 5 into that green square, what does that tell you about the area of the green square with relation to, well, this should be purple or pink, and these should, oh, this is different. So this is yellow and these are orange. I just noticed. So there's just no red in this printer, basically. No red at all in this printer. The red cartridge, the cyan cartridge is out. I think it's cyan. So that's purple. So those 4 and that. So adding those and that to make that, what does that tell you about the area of this and the area of this compared with the area of that? Right, now, or just simply don't have to use the word area because this is for young learners. Just if we put those together and those together, see if we can make that, what does that tell us about this and this compared with this? Okay, now upper primary, I'm going to go back to the screen because, well, I can actually show you on these sheets. It doesn't have to be on the screen. Says she with confidence. Here we go. Here it is. And that way I can kind of point things out. So upper primary, Dieudonné's dissection, like looks, oh, wait, what, no, that's all right. What you're looking at is, I'm going to stop the share because I'm not 100% sure what you're looking at. I think you were looking at the visualizer. I hope you were looking at the visualizer. You are now. Okay, so this is Dieudonné's dissection. This is all in the resource pack. You can see why it's so important to print it out. So you've got the right angled triangle, 3 squares. You want to cut the outline, cut around the outline. Leave the biggest square attached to the triangle, which we will do if we're cutting around the outline. Color the triangle and the square with different colors, color them in with different colors, and cut off the 2 smaller squares. So cut there, you've got the color these two different colors, and then cut the middle size square into 4 parts by cutting along X, WX and YZ. So those lines there, that's where you cut, not the dotted line, but the solid lines. And color the 4 quadrilaterals. So that's that, and that in different colors. And also color the smallest square there. So you cut those off, that's all stays together. That's colored a different color to that, cut that one off, color it a different color, cut that one off, cut across there and there, color 1, 2, 3, 4 quadrilaterals in different colors. This is for upper primary, by the way. This is for 8 to 11-year-olds. And now fit the 5 pieces of the 2 smaller squares. So 1, 2, 3, 4, 5. Fit those into this square on the hypotenuse. So this here is the hypotenuse. That's what that longer, the diagonal on the right. So that's a right angle triangle. And the one that isn't attached to the right angle triangle, that's the hypotenuse. It's a bit like a hippo, isn't it? Hippot. There was somebody, hippo. There was somebody gave me an idea of how to remember it, and I forget what it was. Fit the 5 pieces. So 1, 2, 3, 4, 5 into this square here. Make it match, and then again, what then is the connection between these 2 squares and this square here? And do it with other, make your own, make other draw right angle triangles, draw the squares, and make your own, and see what you can see what happens with that. Now notice that WX and YZ. Okay, you're going to read that once you've solved the puzzle. Look at where WX and YZ, those points, they'll have some relationship with this smaller square, and you're going to look at that, read this once you've solved it. This says, by the way, this is not a proof, but it's a demonstration. It suggests that a result could be proved. Now, this idea of proof is really important. So you can think, well, this looks right. But actually, there's some things out there. There's this crazy triangle where you move it around and there's like a little bit of a square missing from it. And you're like, so you think what you're looking at is a straight line, and it's not. So it's not proof. So you've got to be super careful. Okay, now, and then we're going to go on. There's some nice activity you can do here if you're, once you're ready for that. We've got doing some formulas. Looking at this, now we've got something for lower secondary, so that is 11 to 14-year-olds. So cut all these out, make a square with 6 of the pieces, make a square with 5 of the pieces, and then work out the connections. Again, it's not a proof, but it suggests that a result can be proved. We did this the other day. There's a separate, you can follow this link to the Pythagoras jigsaw. That's gives you much more detail on that activity. And then year 9, which is 14, 15, yeah, about 14, 15-year-olds. This is, I love this, I totally love this. Leonardo Da Vinci was so innovative, so creative. He was an engineer, he was an artist, he was a mathematician, he was a scientist. His mind was on fire. And he was learning and creating, and he wrote backwards. He wrote his books backwards. We're not quite sure, and I think he did them left-handed as well. And so we don't know if it's so that people couldn't decipher what he was saying, or if purely that was the way his brain kind of insisted on recording his learnings and his discoveries. That this is a great way of looking at the same puzzle in a completely different way. So have a go at that one, and that's for specifically, you can, if you're younger, you can do it. If you're older, I'm going to have a go at that one. And then what am I doing? And then, upper secondary, here we go. Then we've got some solutions, not showing you. but they are there. And right, I'm just going to come back to, I think this is all solutions. So you've got guidelines. This you want to kind of let your grown-ups help you with this, rather than, you've got some guidelines, okay? We're not abandoning you with this. But at the same time, we do want you to do the work yourself, and then you can refer to that. Is that on focus? Yes, okay. So for the upper secondary, so that's 16 to 18-year-olds, then do the activity. So answer the diagnostic question. The diagnostic question is on a separate page somewhere here. Well, lost it. Here we go. So that's for secondary students. Answer this question, which is on page 8. And then you don't need to use Pythagoras theorem, okay? You do not need to use Pythagoras theorem. And just basically follow the activity. There's lots and lots of questions. If you've got grown-ups with you who don't know how to do this, you know what? This is a great time for you to learn. Great time for you to learn. If you thought, oh, I wish I understood Pythagoras' theorem, go through this whole activity, and by the end of it, you will actually get it. You will get it. And if you're in secondary school, if you're a teenager and you never understood it, then do this and you'll get it. Go through all the activities, start from the very early, just from the early years one, and you'll get it. And if you are just learning that, it's just the perfect time for you to start doing these activities and get to the point where you're like, okay, I get that. And then come back to it in a few months and do a bit more, or even once a year, keep coming back to it. If you're about 8 or 9 now, it's the perfect time for you to just be doing this. And then when you see it in class, boom, you'll understand it, because you've done the groundwork, you've done the things that help you understand it. So thank you for joining us. If you love these lives, please do share them. This is a long one. This is a 45-minute live. Oh my goodness. If you love these lives, please do share them, and please tell everybody about the group, Making Maths Fun for Kids of All Ages. If you're on YouTube, please do subscribe to our YouTube channels. That's Maths Toys YouTube channel, where we'll slowly but surely putting on videos that just to match each of the activity packs that are home learning guides on the Aiming High website. All of this is provided by AIMSEC and the Aiming High website, and they provide professional development for teachers in Africa. There's high level professional development for maths teachers, and it's provided for free to teachers in disadvantaged and rural communities who have they're hugely dedicated to their work, and we provide it for them. What's the word? Oh, sorry. I love AIMSEC so much. I love their work. That's like, I feel like but I'm actually not. I'm a supporter. I'm not part of the organization. And but they provide these activities, and they're fantastic activities for anyone in the world. And so it's Maths Toys YouTube channel, and Bubbly Maths is where we upload the lives. And also there's other activities with soap bubbles and balloons, and we talk about mindset and maths anxiety and things like that as well. So thank you for joining us. Let's see, I don't think I didn't end up doing, no, I didn't do all the jiggery pokery so I can see the comments. I'm super sorry. I'll have to look at the comments afterwards. I'm sorry. I'll comment on them afterwards, but please do you look at the comments. And yeah, I was so engrossed in getting this done and all the cutting and whatnot that, okay, we'll leave it at that. Thank you very much. And I will see, well, I'll be back in 13 minutes with a live for the early years. And for that, on page, basically print out and do the early years, I've actually, I've made a larger version of this, and we are going to redo it with a slightly larger version, or you can magnify it as well and print out a larger version of it. And we're going to play with that. We're going to, it's literally playing with right angled triangles. If you want to see an early years person do this, I did this with my 5-year-old grandson last night during the live. Thank you very much. And Leo, oh, sorry, you've been talking to a little head again, as usual. Oh, here we go, up here. Leo's not here to stop it for me. Thank you very much. See you later.